This question says, determine the intervals on which the function is increasing, decreasing, and constant. So these words, increasing, decreasing, and constant, these are words that are describing y. So let's get a feeling for the overall sections of the graph by tracing the graph as we go from left to right. So starting at the leftmost part, so the reason why we're going from left to right is because on the number line that's smallest to largest. We want to write our intervals smallest to largest. So as we go from left to right, we can see that the y values are decreasing along this section, increasing along this section, decreasing along this section, and the y values are constant along this section. So I'd like to take a moment and label these different sections. So this section is decreasing, as well as this section here. I'll label that with a D for decreasing. And this section is increasing. I'll label that with I. And this section is constant. Now, when we're asked to determine the intervals on which the function is increasing, decreasing, and constant, we're wanting to write down the intervals of x. We use the x-axis as our kind of map, our way to describe directions on where to look. And so when we write down the intervals, we're going to write down the x intervals for which the graph is either decreasing, increasing, or constant. So I'd like to write down this interval, this first interval that's decreasing, and we want to write down the x where that starts and the x where that ends. So we're going to say that it's decreasing on the interval from, let's see, that looks like -10. And that decreasing interval stops at 0. Now, I'm either going to put parentheses or brackets on these intervals. And depending on the definition that's given to you, in some books, you use parentheses based on the definition. In other books, you use brackets based on the definition. In our college algebra book, we use parentheses, but in the pre-calculus book I use, they would put brackets on those intervals. So we have another decreasing interval here, and that decreasing interval starts at this x value and ends at this x value. So the next decreasing interval is from 4 to 9. And then we have an increasing interval. And the increasing interval is right here, and we can see that that starts at an x of 0 and ends at an x of 4. Once again, our book uses parentheses on this, but pay attention to your book of whether to use parentheses or brackets. So then we have an interval of constant, and that interval of constant will start at this x value of 9. And because of the arrow, it continues on forever in this direction to infinity. So we found the intervals of decreasing to be from -10 to 0 and 4 to 9. The intervals of increasing are from 0 to 4, and this function is constant from 9 to infinity. This question says, graph the equation y equals 4 absolute value of x by plotting points. We're going to complete this table to find the ordered pairs, and then graph the equation on the grid. So if x is equal to -2, we'll substitute that into our equation. And we'll simplify the absolute value first. Absolute value of -2 is +2. And 4 times 2 is 8. So that first ordered pair is -2, 8. Then if x is equal to -1, y will equal 4 times the absolute value of -1. The absolute value of -1 is a +1, and 4 times 1 is 4. So our second ordered pair is -1, 4. Then we'll let x equal 0, and y equals 4 times the absolute value of 0. The absolute value of 0 is 0, and 4 times 0 is 0. So that gives us the ordered pair 0, 0. Then we'll let x equal 1, and y will equal 4 times the absolute value of 1. The absolute value of 1 is 1, and 4 times 1 is 4. So our last ordered pair is 1, 4. We're going to plot these ordered pairs. Get -2, 8, -1, 4, 0, 0, and 1, 4. So we're going to get a V-shaped graph. Comes to a point at 0, 0. Like two straight lines that have been joined together. And that's the graph of our y equals absolute value of x. This question says, write an equation for the line in point-slope form. Find the point-slope form of a line with the given slope which passes through the indicated point. We're given the slope is 4, and the line passes through the point -6, 9. Our point-slope form is y minus y1 equals m times x minus x1. M is where we'll put in the slope. And our ordered pair that the line passes through, we'll use x1, y1 for that ordered pair. So m is 4, and the point is x1, y1. So substituting these values in, we'll have y minus 9 equals 4 times x minus -6. I want to simplify this minus a negative to be a plus. And now we've written this equation in point-slope form. This is an equation of a line with slope 4 passing through the point -6, 9. Another example here. This question says, determine if the function is even, odd, or neither. And our function is g of x equals square root of 4 minus x to the 6. So when we're determining if a function is even or odd, we should know the definition. The definition of even will be if f of -x is equal to f of x. And these are some symbols that represent y-axis symmetry. And so what that means is you would have a mirror image going over the y-axis. When a function is odd, it would satisfy the definition f of -x is equal to -f of x. And this is a symbolic way of representing origin symmetry. When you have origin symmetry, that's when you're symmetric in opposite quadrants and you have that mirror image going over the origin. So for us to figure out if this function is even or odd, I'm going to do a calculation, and you'll notice in both definitions we use f of negative x as a part of the definition. So I'm going to do the calculation g of negative x so that I can compare whether our function matches this definition, which is when f of negative x equals f of x, or if it matches this definition where f of negative x is negative f of x. I like to think of these as the same and the opposite. So the first one, which is even, equals, the two y values equal each other, and you can see that the y values are the same here for these points. And opposite, we've got a negative here, and these y values are opposite of each other when we have origin symmetry. So I'll do the calculation g of negative x. Everywhere I see an x, I'm going to change it to negative x. And negative x to the 6th power, that's an even number of negatives, and those negatives will cancel out. And so you can see my calculation of g of negative x is equal to the original or the same as the original. And so this is fitting with the definition of an even function. This function is even, and if we were to graph this, the graph would have y-axis symmetry. This question says, determine whether the following equation represents y as a function of x. Our equation is 4x minus 3y equals 12. And in order to determine if we have y as a function of x, we want to rewrite this equation with y equals. So I'm going to solve this equation for y. I'm going to subtract x on both sides, subtract 4x. That's negative 3y equals negative 4x plus 12. Then I'll divide every term by negative 3. That's y equals 4/3 x minus 4. And now we've written this equation with y equals, and it's written in the form of y as a function of x. This equation is a function, but let's go into a little bit more detail about y. The definition of a function is that every x has exactly one y. So every x that I substitute in should produce exactly one y. We can go through a few examples of those x's. I'm going to pick some nice ones that will work out easily. For instance, if I choose x equals 0, then y would equal 4/3 times 0 minus 4. 4/3 times 0 is 0 minus 4 would be negative 4. So my x produced one y value. If I choose another x, like 3, I chose 3 so that I don't have to deal with fractions. My fraction, my denominator will cancel out. Y equals 4/3 times 3 minus 3. The 3's cancel, leaving me with 4 minus 3, which is 1. And my x value produced one y value. We can do another one like x equals 6, and y would equal 4/3 times 6 minus 3. 3 goes into 6 2 times, so I would have 8 minus 3, which is 5. So hopefully you see a pattern here that no matter what x I'm choosing, that's only going to produce one y value, and this fits the definition of a function.